Dear students, welcome back to this session. This session is on a very important topic which is known as influence line diagrams. It is abbreviated as ILD. And you know, the application of influence line diagram is for the bridges where the vehicles continuously move over the bridges. That means the application of influence line diagram is about moving loads, the loads which are not at rest, the loads which are continuously in motion. So before I tell you what is the meaning of influence line diagram, let me take one example and make it very simple. So this is a simply supported beam, you all know that. Just imagine that there is a unit load 1 kilonewton. A unit load means 1 kilonewton load which is moving from end A to B. You can see the span of the beam is L. And the unit load, it is in its journey from A to B. That means from A to B it starts moving. At any position, I say that the unit load is at a distance x from A. Now for this position of unit load, let us find out what are the reactions at A and B. You know what is the formula for finding reaction? When any simply supported beam is subjected to a concentrated load, the formula for reaction at A is WB by L. What is B? The distance between the load and the other end. So B is, this is L minus X. This is B. And A is X. So the reaction here is WB by L. W into B is L minus X upon L. What is reaction at B? Reaction at B is load into other distance, that is X upon L. W into X upon L. Now these are the formulae. This is WB upon L, this is WA upon L. A is X, B is L minus X. So these are simple reaction, or else what you can do is you can simply find out the reaction by taking moment about B equal to 0 that you have learnt in strength of materials or elements of civil engineering. So when the unit load is at a distance X from A, or when the unit load is moving from A to B and it occupies a position where it is at a distance X from A, the reaction at A is W into L minus X upon L. W is equal to 1. So it is, instead of W, it is 1 into L minus X upon L. And here also W equal to 1. So the reaction here is L minus X upon L and X upon L, because W is equal to 1 kilonewton. Now for this position of the unit load, you can see the reaction at A is equal to L minus X upon L. Now let me substitute X equal to 0. What does it mean? That means that unit load is at A. It means that unit load at A. When X is equal to 0 means unit load, it travels from A to B. When X is equal to 0 means unit load is occupying position A. At that point, what is RA? Substitute X is equal to 0. So L minus 0 upon L, which is equal to 1 kilonewton. Now substitute X is equal to L. What does it mean? When X is equal to L means unit load has come to B. That means unit load at B. When the unit load is at B, again what is reaction at A? Reaction at A, substitute. The formula, general formula is L minus X upon L. So L minus X is equal to L again, because X is equal to L upon L. That means it is 0. So you can understand that reaction, it becomes 0 when the unit load is at B, and reaction, it becomes equal to 1 kilonewton when the unit load is at A. That means it varies from 1 kilonewton to 0 kilonewton. So if you plot, you will get a diagram like this. So it is 1 kilonewton and this is L, the distance, and this is position A, this is position B, and it is 0 here. So this diagram, you can see what is this ordinate? This is reaction at A. What are the other ordinates? How many ordinates are there in this entire figure? Innumerable ordinates. You cannot count. At each and every section, you can see all the ordinates, they represent reaction at A only. So this is reaction at A. This is reaction at A. Any position you take, for instance, you take this any position at a distance X. What is reaction at A? We have seen at any distance x, the reaction at A is equal to L minus x upon L. L minus x upon L. So this diagram, how does it look? It looks like a triangle, right angle triangle. 1 kilonewton here, 0 here. And this diagram represents only reaction at A, but for various positions of unit load. That means unit load, when it starts moving from A to B, the reaction at A will be like this. That means when the unit load is at A, reaction at A is equal to 1 kilonewton. When the unit load is at B, reaction at A equal to, it is reaction at A only, not reaction at B. So it's all about reaction at A. When the unit load is at A, reaction is 1 kilonewton. When the unit load is at B, reaction is 0. When the unit load is at a distance x, the reaction is L minus x. So this diagram, it gives influence of unit load for the reaction at A. That is why it is called influence line diagram for reaction at A. Influence line diagram for reaction at A. Now, if you want to draw influence line diagram for reaction at B, you know what is the general formula for reaction at B? We have already seen. It is x by L. Put x equal to 0. That means unit load is at A. When the unit load is at A, that means that unit load at A. When you put x is equal to 0, what you are going to get? RB equal to 0. Again, put x is equal to, like what we have done for RA, I am doing for RB. X is equal to L, which means that unit load at B. So when you put x is equal to L, L by L, RB equal to, or simply 1 kilonewton. So reaction at B, it varies from 0 to 1 kilonewton when the unit load moves from A to B. So when you plot, you are going to get a figure like this, exactly reverse. 0 here when the unit load is at A, and 1 kilonewton here when the unit load is at B. And in between, what is that reaction? That reaction in between, where the unit load is at a distance x from A. It is given by the formula x by L. And this diagram again, it gives influence of unit load over the reaction B. That means it is called influence line diagram for reaction at B. So you should understand what is meaning of influence line diagram for reaction at A and what is meaning of influence line diagram for reaction at B. And each and every ordinate in the influence line diagram for reaction at A is nothing but reaction at A only. This is reaction at A. 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 All these are reaction at A. But for various positions of unit load. Similarly, this is reaction at A. B. This is reaction at B. This is this. All these are reaction at B only, but for various positions of unit load. That means what we have done, we have made the unit load to travel from A to B. That means unit load moves from A to B. When the unit load moves from A to B, what is the influence of that unit load over the reaction A? That is given by this diagram. That is why it is called influence line diagram for reaction at A. What is influence of unit load over reaction at B is given by this diagram. It is called reaction at influence line diagram for reaction at B. So this is ILD for RB, this is ILD for RA. So this is very important, and like this we can do influence line diagram, we can plot influence line diagram for bending moment and shear force at any section. I hope you have understood this.